We'll now try to show convection currents in water. To make it visible, I'm going to add a chemical called potassium permanganate to the water. Now, you don't need very much, just one or two small crystals are sufficient. And I'm just going to drop those along the side of the beaker of water, so they go to the bottom. You can get potassium permanganate from a chemical supply house, or failing that, you can go to your local high school and ask us for a small amount of potassium permanganate. A little bit goes a long ways, and so once you have some, you can use it for many years. I'm going to now take my alcohol burner and place that just under the crystals at the side of the beaker. Watch now the purple dye, the purple current, as it moves up the side of the beaker. Why does it move up? Well, when I heat the water expands ever so slightly, making it less dense and therefore rising in the rest of the water. And as it rises, it carries along with it a small amount of the dye, the potassium permanganate, allowing us then to actually see the movement of the water. Another way to show the effect is to take some food coloring and put a small amount in a disposable dropper. So what I'm doing is sucking up a little bit of the food coloring into my dropper, and then dropping that to the bottom of the beaker. So the food coloring sits on the bottom, and then place the burner under the food coloring. Now watch the movement of the food coloring as the water is heated up in the side of the beaker and now rises. Again, it's important that the water itself be very still before you put the food coloring in, so that there's no motion in the water to mix the food coloring around. And if you don't have a nice glass beaker, you can always use a pop bottle, and we'll lower the food coloring into the bottom. And then we'll take our alcohol burner, as we did before, and place it under the portion where the food coloring is. And again, you can see the food coloring rising nicely as it's warmed up, as the water warms up and sets up a convection current within the liquid. Now you can ask the question, why doesn't the pop bottle burn? Well, that has to do with the fact that the water conducts the heat away from the plastic, preventing the plastic from reaching a high enough temperature to melt